Hi, everyone. Thanks, everyone, for being here, and thanks to all the great talks so far. Um, so, y'all might have seen earlier this week on Tuesday, we released actually three Wasmtime security advisories. Say two are pretty minor, one of them's a big deal. This is about work that has to follow on from that. The advisory itself, I am not going to read it to you here. It's very well written. You should go and read it. Um, this guest control resource exhaustion of WASI implementations is the title. What does that mean? It means that uh, if the guest does something, it can cause a WASI implementation to allocate a lot of memory or otherwise do things to exhaust resources in the process, right? And we didn't have control over that prior to this patch. That's frankly an oversight. It's been in WASM time since day zero, or since the very first time WASI was ever implemented, essentially. Um, so some credit on this work. First off, we actually found out about this because a brand new contributor reported a memory leak and sent in a patch for that leak. It happened to be in the Wasmtime WASI's preview one info. So really cool that mbund did that report for us, and they sent in a totally good patch for the one particular issue they found. Um, Alex was the one to field or triage this because he wakes up before us West Coast people, and he does way too much work anyway. Uh, he took a look at it and was like, "Oh yeah, this is a legit bug, but also this is just one little piece where we're allocating and a large amount of memory and happen to be leaking some of it. That's controlled by the guest." So Alex kind of took it and took a look at this and said, yeah, we should fix this whole category of issue rather than play whack-a-mole with this. And then, of course, the next security advisory fixes the next little one and so on. So thank you to Alex for doing most of the investigation remediation. I was able to help out a bit. Alex was preparing a different talk, so I offered to give this lightning talk on this while it's timely. Okay, so what did we do, or what did we find that the guest can consume host memory? Um, by the way, this is all assuming the component model, and it happens to be that the preview one implementation gets implemented in terms of the preview two implementation internally, so kind of all applies there. Let's not talk too much about the preview one stuff because it kind of doesn't matter. It just kind of falls out. Anyway, okay, so by creating component model resources, right? If the host provides a vector like, for example, opening files, right? Every time you open a file, it creates a new component model resource for that file. If you were to open the same file in a loop forever, you would eventually, I guess, get to the 2 to the 32 index space before you trap. And because there's more than 1 byte, you'd be able to consume many gigabytes of host memory if you were to just sit there and open a file in a loop, is the short answer. So now there's a new limit on that. Of course, all of these constructors, they're not fallible, right? We don't have a way to return or something like that, like all that work Nick was doing across the component model boundary, right? So now if you hit the limit, it traps. And in general, that's going to be the theme here as you go down the page. And there's lots of other things in WASM where if you reach a limit, you trap the so-called implementation limits that all the web VMs have, and Wasmtime follows. But those tend to be on things that you can analyze about a module. This is things that happen at runtime. So that's the difference here. Okay, so we said we did create a resource, but now let's look at more specific things, right? Any import function that accepts either a list or a string, which is to say lots of useful ones accept lists or strings. Those are very useful things. If they accept really large, you can in the guest give them a really large list or a really large string. So when you pass that to Wasmtime, what Wasmtime will do is allocate a vec or a capital S string, which is under the hood of vec, in the host, and copy all that information out from the guest to the host. So again, that was only bounded by the size of a linear memory previously. And so now we've got a limit on the total size of lists you're allowed to, lists and strings, you're allowed to allocate in the host across a single import function call. So if for whatever reason you accept 3 lists through a call, or worst case would be a list of lists, which would allow you to do quadratic, right? Um, uh, you'll now, each time you allocate something in the host, it'll count against a fuel limit. When you reach that fuel limit, Wasmtime, rather than continuing to allocate things in the host, will instead just trap that whole import function. Okay, and then so those two are actually really easy. We were able to take care of those with a limit that takes care of all of them. Then there's the hard case, and that is some particular import functions. They take an argument, and it happens to be that calls an allocation that's not straightforward from the types, right? So the first example is stream or file read, right? When you say read, you say, how much do I want? The size argument, right? To U32. And Wasmtime will dutifully allocate a bytes mute, which essentially a vec of U8 of that size, and then do a read into it, and then pass the ownership of that over to the guest. So that is, again, a way where an integer in the argument can make a big allocation in the host, right? So if you were to pass 2 to 32 there, and you were on a system that didn't overcommit, or you were near the limit, or something, that could you. Or at very least, it could contribute to the memory pressure of the system and so on. So it just so happened we already had a maximum read size allowed by the spec, and you could always read less than you were asked for. So it's cool. Like, we just capped that one, right? We were able to look at that case and say, all right, well, you asked for 4 gigabytes of read, but we're only going to give you 64 megs at a time. And then in user land, your program will gracefully, then go and read the rest of what it needed in chunks. So that one's not in red because that one's not that bad. One that we encountered that we didn't have an escape hash like that was get random bytes, right? In the random interface, you say, I want this many random bytes, and the function is just U32 argument 2, list of U8 result, right? So there's no fallible. There's no way of saying, oh, I'm giving you less than that number of bytes, or you asked for too many. So now if you ask for too many random bytes, it just traps. That was a choice we had to make there. That would break user land the least. It's not a choice we liked making. But there's a new limit on that, right? And then the last one was HTTP fields. This is in the WASI HTTP proposal. When you make fields, is just the synonym for headers and trailers because they're the same structure. It basically gives you a way of saying, okay, here's an arbitrary key value pair, the value being a vec of bytes, right? Just unbounded in size. And you have to tack that on an append. There's the .append method, right? Tack that on and append that to this resource. The resource has to own forever. So now we say, okay, you're only allowed to allocate up to 32K for that stuff total. There's a new limit, right? It ends up being that for anything that's web interoperable, more than 8K of headers tends to stop at various proxies by default. That one probably doesn't break as many well-meaning programs, is the point. By the way, as a bonus, we also found another security advisory where the HTTP creates header map thing would panic because we made a bug. HTTP crate probably didn't have the best API design anybody's ever seen. So there's like a less consequential advisory, or sorry, a less interesting advisory that is consequential that was fixed as well in the patches that just came out on Tuesday. So I want to like the part of this talk of like, what do we do next? I just said what we did. And what we did was security mitigations. We did not come up with long-term solutions to the problem, this category of problem that we uncovered here that we didn't really consider well enough prior to this incident. And by we, I mean, me and many other people who worked on this code for years. This was just an oversight. But, the consequence here is we broke user land. That's the thing you're not supposed to do, right? the one I worry about most is random, right? Because it's just like, oh, libc will just pass that through. There's well-meaning programs that might have wanted a whole bunch of randomness. And how do we know that we didn't just cause a valid program to trap? The number of resources is similar to the file limit in a Unix process, where it's like, okay, well, now there's potentially well-meaning programs that trap. Luckily, there's not a lot of WASI programs out there that are doing super opening a whole lot of files, just kind of by design. But you know, this is unfortunate, is my point. Also, uh, we did so unilaterally. We broke these programs unilaterally. Like Alex and I we're in a security issue. We couldn't like make this a WASI issue and talk about it for a month or two and collect lots of community input before we did this. We had to get a patch out within a week, so we had to make these decisions within days. So this is to say, what we chose on a mitigation timeline doesn't mean now we can't get community input of like, were these the right choices? We can still we broke user land, but we can change the way we broke it over time because we did so for security mitigation. We weren't following a standard by breaking user land here. And I think the biggest thing in my mind that's a problem about this is, when I say we set limits, what we did was we chose default limits in Wasmtime that seem to make sense to us. And there's always a knob, whether that's you're an embedder, they're on WASI context builder, WASI HTTP context. There's a knob to change the limits, or those turn into Wasmtime CLI flags if you're using Wasmtime on the CLI. So the idea is like, okay, well, you could change these limits, right? We made a knob, but the guest can't know what you chose as your limits, and it's gonna trap, right? So not only can we make WASI libc and dubstud and other places like respect the default limits, which I haven't done yet because of this we did so unilaterally thing where we want to kind of let this marinate a bit, to find out what the long-term issue is or long-term solution is here. If those limits change, there's no way to discover them. So that's undesirable. It might have to always choose to do that in some cases, but that's undesirable. The real call to action for all of you on this call or watching is, Alex and I patched this in Wasmtime WASI and Wasmtime WASI HTTP and the Wasmtime CLI that's built on top of those. If you are not just using those implementations and pulling in the patches on them, you probably have to go and do that special case discovery, the stuff where we found file reads, random, and HTTP fields, right? You have to go through your code base and audit it. If you have interfaces that are not part of those, CLI world and proxy world interfaces, you have to go and audit those and the implementations of them and discover whether you're susceptible to this. So that's probably the most dissatisfying thing about this whole process to me is we uncovered a new category of things we hadn't really thought about. And it's not just us. I mean, like Wasmtime, we did our job with the Wasmtime project and its scope, providing security fixes for this. But if you're an embedder of Wasmtime, you may and probably have more work you have to do. So this is kind of a PSA to please go do that. And finally, what do we do with the standards? Like I said, we did this all without community input. This is a big amorphous design space that we have definitely not explored. So the first step is, and this part of what this lightning talk is to kick off, is socialize some actual plans, figure out in the standards, figure it out in the Wasmtime repo if necessary, of what a long-term solution to this looks like. And that can include questions like, does the component model spec take on the resource and lifting fuel implementation limits? It should probably describe those. Does it specify what the limits are? I don't know. There's a lot of open questions there, and this talk is not about trying to answer any of them. Of course, the WASI P1, the WASI P2 specs are done. We're not going to make breaking changes to the functions that we had to change where they might trap. So we need to document if we agree on the way they should behave, that they may trap. uh, in those cases if we settle on that. And finally, the WASI P3 spec is not out yet where we can't make breaking changes. So can we make any design changes to WASI P3 now before it's out that will save us from having to have unfortunate trapping behavior that's only found in the spec text? Or if we do have to do that, we can at least settle on it before the spec goes out. So I know that release is coming soon, and a lot of people are counting on that. And I totally get, having been the release manager of this before, how tricky it is to do things at the last minute. But I just want to call that out as a to-do, to talk and think more about it. So anyway, Alex filed issues on the WASI repo, 888, 889, and 890 to go and talk more about these. That is all from my talk.